Hello everybody, welcome to my channel Programming in C with RSK, and I am your host Rajendra Kulkarni. Friends, I have uploaded many videos up till now on various features and topics of C programming. This is the 23rd video I am uploading. I request you to please visit my channel Programming in C with RSK. It's available on YouTube at ID of Rajendra Kulkarni 7333. Please view my videos, like those, share those, and subscribe to my channel. Friends, in this video we are going to discuss about the calling conventions followed by functions in C. Calling conventions are the specifications followed by compilers for execution of a function in those respective programming languages. So calling conventions are specific to a language. In C, what are the calling conventions that we will see? We will start first with a small program. A function void calcon with 3 float values as its arguments is declared. Float a is equal to 10 is the variable assigned with value 10. Then we call function calcon. In this function we are having 3 arguments. One is a, another is a is equal to POW a comma 2. It actually is gives us the value of square of a, which will be assigned to a, and a is equal to square root of a. These are the 3 variables, or these are the 3 function parameters, or the 3 actual arguments which we intend to pass. Now we can see here the first argument is a variable a, the second argument is a again, but now its value has been modified, or it has been squared. The a will now have a value which is evaluated by this function POW, which will be actually 100, and the third parameter or the third argument is square root of a. That square root of a will be assigned to variable a, and then the values of 3 values will be passed to the function calcon, where those values will be collected in 3 float variables x, y, and z. This function only does a statement printf. It only executes one statement printf, which will display the values of x, y, z as they are received from the function call. Now what we expect will be the output from this program. My expected output is a is equal to 10, so x will be 10. A is equal to square of a, which is square of 10, which is 100. So y should have a value of 100, and z will have a value of square root of a, which is 3.16, and so on. When I ran this program, the screenshot shows that x is 10 as expected, y is 10 instead of 100, and x is 3.16. So what is the issue which caused the actual output different from expected output? When we analyze these outputs, what we can determine is, first a is equal to square root a, sets the value of a 3.162278, and that value is passed to z. Then a is equal to power of a raised to 2. Now a is having a value of 3.1622. So when it power of a raised to 2 function executes, a becomes 10 and passed to y, and lastly a is passed to x, which has now acquired the value of 10 by virtue of this p a is equal to POW a comma 2 expression or function. So what we find here is the values in the actual arguments were passed to calcon function from right to left. So the rightmost parameter was passed first, then the middle parameter, and then lastly the leftmost parameter. First a is equal to square root was passed, then a is equal to power was passed, and lastly a was passed. We can also see here that the expressions of the actual arguments are first evaluated, then their values are assigned to the variable a, and those values are passed to the function. So what is calling convention? Why the function in this program the values were passed from right to left? What happens is the microprocessor which executes all our programs, it executes the program sequentially from one instruction to the next instruction, and also it can execute only one instruction at a time, and all these instructions must be available in the memory, the data as well as instructions. When there is a function call in the program, the microprocessor execution of the program jumps to a new location where the function has been stored by the compiler. Let us broadly see the conceptually how this is working. Whatever we are going to discuss is not the actual happenings that are taking place in the execution of the program. These are conceptually we are discussing. So when the program is loaded and is available in the memory, let us suppose that the first instruction of our program, which is a prototype declaration, is stored by the compiler in location number 100, memory location number 100. This is only a conceptual understanding, because such a long instruction will never be stored in one memory location. In actual case, it will take at least 5-6 locations, but here we are only discussing conceptually. So we can assume that this first instruction is stored in 100, and subsequent instructions are stored for the main from 100 to 106. So when the program reaches the stage of function call, c is equal to add a comma b, this function call will cause the program execution to jump from 104 to the memory location 300, because that has been the assumed locations which the compiler has allotted for storing the functions definitions. So when the program jumps from 100, location number 104 to 300, at that time it also passes values of variables a and b to the values of variables a and bb, which are the arguments or the formal arguments of the function definition. Since microprocessor can execute only one instruction at a time, it cannot pass the values of a and b to a and bb parallelly. They has to be done sequentially. Now the question arises whether the first a is passed to AA or B is passed to BB, which comes first. This sequence of passing the argument values is decided or determined by calling convention. Calling convention is a standard. It's not a part of C language. It is a part of compiler and the operating system, and the microprocessor used decides the compiler's design and the sequence in which values are passed is designed or is abided as per the calling convention adopted by the compiler of the C program here in this case. CDECL calling convention is one of the calling conventions. There are 4 or 5 calling conventions. One is CDECL, another is standard calling conventions, STD call. But we are going to discuss here only about CDECL because it is the default calling convention for C programming in Turbo C language. The calling convention is a standard which specifies how function calls are executed in any programming language. So for every language there can be different calling conventions, default conventions. In C it is CDECL calling convention, which is a default one. Actually what it does is it specifies how function calls written in the programming language, or in this case written in C, are converted to assembly language code by the compiler. So when a program is executed, when a C program is executed, what compiler does is it compiles the program first, converts it into the assembly language which is applicable for the particular system, and then that assembly language code is executed for execution of our actual program. So language doesn't define the calling conventions, but the calling conventions are heavily dependent on compilers, operating systems, and the specific microprocessor being used in a particular for which the C programming compiler has been designed. What convention says how the variables and the data of the calling function and called function is preserved on the stack during call. What we see in the earlier slide is the program main function or main of the C program was doing some activity. It was running using some data or from the program specified in the program, and then there was a call to the function which caused it to jump from the memory location which it was executing at that time to a new memory location which is totally different from what it is in the main. So the data available within that microprocessor during when it was executing the main function has to be preserved, and that preservation takes place on transferring the data from the internal registers of the microprocessor to the memory location called stack memory during the function calls. How that happens, what is that mechanism, we are not going to see in details here. We will be making a new and a different video on stacks and functions. What we understand or what we should know is calling function and called function data is to be transferred to the stack, and how that data is to be transferred, how stack operation has to be carried out, is decided by the calling convention depending on the microprocessor's capabilities and microprocessors of systems. Then another thing is how arguments are passed to the function. CDECL calling convention causes the passing of arguments from rightmost to the left. How function returns the value, where that value goes, that is also decided, specified by calling convention. In CDECL, the function returns the value and it is stored in the accumulator of the microprocessor. In some cases, in some different calling convention, there can be a different way how values are stored when the function is returning, when the return values are stored. See, stack is having a lot of data on it when the function call is in progress. When the function returns, all that data becomes redundant, and hence it has to be cleared, the stack has to be cleaned. Which function cleans the stack, whether it is a calling function or a called function, is also decided by CDECL calling convention. In CDECL, calling function cleans the stack. Arguments are passed right to left, and value is returned to a register called EAX register. From that register, the compiler picks up the value and assigns it to various variables as per the program which it is executing. The earlier program which we saw, it demonstrated that the passing of variables or passing of arguments is from right to left. So this is all about our today's topic, calling conventions. Please visit to my channel, subscribe to my channel. I have uploaded up till now 22 videos. This is the 23rd one. All these videos explain various features in C with theory, and also with each video explains the features with at least 2 or 3 programs. My upcoming videos are on these: processors, preprocessor, pointer to functions, storage classes, arrays, structures, files, 2D and 3D arrays, strings, and many more. So please keep watching my channel, Programming in C with RSK. Thanks for watching today's video.